In this video, I am going to talk about Oracle AI Vector Search in Oracle Database 23AI. I'll begin by explaining the concept of the vector data type, vector embeddings, and embedding model. Then, I'll show you how to import an embedding model into Oracle Database 23AI and Oracle Cloud and how to use it effectively within the database. And after that, I'll focus on similarity search. I'll discuss what is similarity search, how it works, and how you can perform similarity search by using Oracle Database 23AI. If you prefer reading, you will find all the code and explanation of this video in an article I've written, and the link is below the video in description, as you see here. And one more thing I'd like to mention is my focus in this video is on a database hosted in Oracle Cloud. And in the previous video in my YouTube channel, here created database 23AI, this one, and also in the previous article in my blog, you can find how you can create a database 23AI in Oracle Cloud and connect to this database by using SQL Developer and SQL Plus. If you are not familiar with this topic, before continue watching this video, I recommend you read this article or watch this video to know how you can create a database on Oracle Cloud and connect to this database with SQL Developer or SQL Plus. Let's get started. What is vector data type? Oracle Database 23AI introduced a new data type called vector. In vector data type, we can store vectors or vector embeddings directly in our table in database. But what is vector? What is a vector embedding? Simply, we can say a vector is an array of numbers that show the semantic meaning of an unstructured information. Unstructured information, for example, text, video, voice, picture. But the question is how we can create these vectors. And the answer is by using embedding model. Actually, embedding models are responsible to create vectors. And this is the scenario. We give our unstructured information, for example, our text, to our embedding model, and then our embedding models generate the vectors. As you see here in this scenario, embedding model has a key role. So let's focus on that and see what Oracle Database 23AI has about embedding model. Database 23AI supports ONNX model. It means you can upload your model on your database and then in your database generating your vectors by using SQL language. There is a function, for example, it's called vector embed. By using this vector embed function, you can generate vectors for an unstructured data like text. So I'm going to focus on that and show you how you can import your model, your ONNX model on your database, and then how you can generate your vectors for a text. Now I focus on how you can load your ONNX embedding model on your cloud, and I assume that you've already created a database 23 instance on your cloud, and the next step is your selecting your model. And so in Hugging Face you can find a lot of models. Choose one of ONNX model based on your requirement, based on your data. So after selecting your model, simply come to storage and then bucket, create bucket, just a name and then create. Click on that. At the bottom you can see upload. Click on upload. So bring your model. This is the model I selected. This is a model from Transformer sentence transformers library, and this model is used for convert from sentences or text to vectors. So I put a name, my model is okay, so upload. So it's take short time, so I pause the video until this finished. So and now as you see my model uploaded, so just close it. So we upload our model into storage on our cloud, The next step is we want to upload this model in our database. So for this purpose, we need to create a credential. What is credential? Credential is a secure object that stores a username and password, and it's used to allow our database safety access to an external resource. For example, this file here on our cloud is an external file, and we want to allow our database has accessibility to this file, and for this purpose we should create a credential. For creating credential, we need username and password, and then for loading the data, we need the URL of this. For the finding the URL of this file, our model, click on view object, and then here just copy this and keep it in a text file, then cancel it. Okay, now as I said, we need a username and password for creating credential. For creating a credential and finding your username and password, go to this profile and then user setting. So this is your username. Okay, this is my username. Okay, so for password, here in the top tabs, click on tokens and key. Come here, auth token. Where is it? So let me delete this. And then generate token. Just a name. Okay, then generate token, then click on copy and then keep it on your notepad here. Okay, just copy what you paste, what you copied. So now in our notepad we have a URL, we have a username and password, and as I said, for creating credential we need our username and password, and for loading our model we need this URI. So let's create a credential. For creating credential, you should run this code. If you have a credential, you can, by using drop credential procedure, drop it at first and then create it. This is the username and password we have in our notepad, and so I run it and I have this credential. Then you can load your embedding model. So let me check I have the model or no. So I think so. Okay, so let me drop. So for load or drop the ONNX model, you should use this package, DBMS vector. So let me drop it, and then now I do not have any embedding model. And then by using load ONNX model here, set a name for model name, what you want, and then for credential, this is the name of the credential here you created at the top, and for URI, this is the URL of the ONNX model that you have in your notepad. So here just run it to load our ONNX model on our database. So by this easy way, we imported our model in the database, and now for testing, so by this function, as I said, vector embedding function, this is a function that returns the vector, and by this model that we used, we can convert our text to vector, and this is the format. The first parameter is the model name, and then using a keyword, and then what you want to convert to vector, and then a label for your input. And so for example, if I want to convert this text to vector and test my model works or no, I can run this and see our vectors. This model I used has 384 dimensions, so I have 384 numbers in this arrays of number in my vectors. Until now, we understood how we can generate vectors by using embedding model inside our database. But assume we've already generated all vector embeddings for all our text, and what is the benefit of them? How we can use it? How do we leverage these vectors inside an application? This is where the similarity search becomes essential. The similarity search actually measures how closely a new query vector matched with the vectors that we've already stored in our table in database. And this is the workflow. We give our input text. This is what we want to compare with our vectors in the database to our embedding model. So our embedding models, by responsibility that has, generate the vectors for these input text. And then Oracle give us two functions, cosine distance and vector distance. These two functions used for similarity search. What is difference between cosine distance and vector distance? Simply I explained, I don't want to make it very complex. You can search more about it, but simply cosine distance, as it seems, computes the cosine distance between two vectors, and it's commonly used similarity search between two vectors when you have text data and for natural language processing scenarios. Most of the time cosine distance is very useful, but vector distance is more flexible because it has the third parameter. In third parameter, you can change the mathematical solution. The default of this parameter is cosine, but you can change it, for example, to Euclidean. When it's good that we change it. So, for example, when your data is geographical, when your data is shape, this is better that instead of cosine distance, you compute the Euclidean distance between two vectors. Now let's dive into leveraging similarity search with an example. Imagine this scenario. We have a table. In this table, we want to store the resume of our candidates or our employees of the company, and we want to upload the resume as PDF or Word file, and then we have some job description or project description. We want to determine how well each project description match with our resume and to what degree. So here, as you see, I have a table. In this table, I have a bill-up for uploading PDF or Word of the resume, and I have two club data type, one of them for text and one of them for HTML. The resume text extract the text of the bill-up, and I used Oracle text for this purpose. And here I want to keep the HTML because I created some samples resume by this format, and all of my resume, for example, I have this template and all of them generated by this template, and I want to show in my application exactly this format. I will show you in the application later. And also we have a vector data type for the vectors of each resume. So as you see here in my table, I have some samples. So bill-up file for the resume and text, and then HTML and the vectors for each one. So now here I have some job description or project description. As you see here, this is one project description. Here I can use cosine distance and understand this, for example, project, how well match with each candidate. So for example, this candidate is matched with this project description with 89%. And so let's test the other one, and then I'll show you in the application. So for example, this project description, so as you see the result. So now I'll show you in the application the resume match application that I created by this AI vector search, this table, and Oracle Apex. So here, as you see, I have an application created by Apex. So here I have an interactive report with form, and as you see here, I have candidate name, resume text, and as I explained about resume text HTML, I said I'm going to show my template in Word or PDF, and this is where I used resume text HTML. So let's test and upload one resume and see what will happen. after uploading each resume, I have resume text, I have resume HTML here, and also in the database here I have for this was for this person vector generated. Now I'm going to test similarity search, and for example I'm going to look one project description how well match with this available resume. So here I have a prompt, so here I have some samples. For example, this is one project description, and I'm going to see which person is matched with this and how much. So for example, this person with this number 89% match with this resume. So I said more than 50% have a highlight. And so for example, the Kai, where is Kai? So here as you see, his resume is this, and what we look for that is this. So let's test the other one, for example, by the other alphabet. So for example, this person 75% match. So for here as you see, he is a Python developer that has Azure SQL and so on, and I was looking for a candidate with experience in Azure and as a Python developer. So let's go ahead and test the other one, for example this one. So by this way you can understand the meaning of similarity search. So this person here, it was about the Java developer, and this resume is matched with what I was looking, and the match percent is 65. Let's discuss how I implemented this application. So in the first step, I want to upload my bill as a PDF or Word, and then I should convert this bill to text. So for this purpose, I used Oracle text here, this CTX package, and this function. So in the last parameter, if you set false, you have the HTML of your Word or PDF, and if you set it true, you have the text of your PDF or Word. And then then I have an update for my table, and for resume vector, as I mentioned several minutes ago, by using vector embedding and your model, you can convert your text to vectors. And this is for preparing the table. And after that, for similarity search, when I click the button, I use this code. So here I use cosine distance. First I change my prompt, what I'm looking for that as a project description, to vector, and then I compare with my vector data in my table. And the reason I used 1 minus cosine distance is a number between 0 and 1, and whatever and it showed the distance between two vectors. So whatever the distance is fewer, the similarity is more. So this is the reason I used 1 minus to show from the maximum to minimum. So just this, and thank you for your time.